Hi, welcome to this new video about vectors, and remember to subscribe to our channel so you get notifications about all new videos that we are going to create. In this exercise they say four forces are heard on the object that is given below. Forces are measured in newtons, abbreviated as M. The net force on the object is Fnet and is equal to F1 plus F2 plus F3 plus F4, what is equal to 4i in newtons. So basically they say that we must find which are the values of the force F3 and the value of the force F4, and we must give the answers in component form. So the first that I want to do in this case is to, given that I know the net force on the x direction, I know that the net force on the x direction is 4.0 I newtons, right? I can say that the net force in x, right, is what I will say there is f2 cosine of 20 degrees, so f2 sub x, right, minus f4, right? So what is f net? The net force in the x direction is 4.0 I. So we say that 4.0 newtons is equal to, what is F2? F2 is 6.0 cosine of, in this case, 20 degree, 6.0 newtons, cosines of 20 degree minus F4. This will be if I just bring, subtracting to the left the 6.0 newton cosine of 20, get 4.0 newtons minus 6.0 newtons cosine of 20 degree equals negative F4, and then I get 4.0 newtons minus 6.0 newtons cosine of 20. It would be 5.64 newtons equals negative F4, so it would be negative 1.64 newtons in this case. Let me erase this part here. So negative 1.64 newtons equals negative F4, so F4 would be 1.64 newtons. If I now express F4 as a force, right, as a vector, I can say that F sub 4 is equal to negative 1.6 newton I, right? This is F4. F4 is pointing to the left, so it's negative, right? Because it's against the direction of the positive x-axis, and the unit vector I points in the positive direction of the x-axis. So that's why we have to use negative sign here, to represent the direction of F4. So it's force sub 4 is equal to negative 1.6 newtons I. Now, in the same way, when they say, that this net force is 4.0 I, implicit there is another information here. There is that is plus 0.0 J, right? And of course this is in newtons. Okay, So I know the component of the net force, right? In the in this case, y-axis. This is the net force in y. You know, well, this is the net force in y would be, if I say net force in y, it would be 0.0, oh yay, in Newton. So I know the net force in y. So we say the net force in y is equal to, and then I have in this case F3, you know, plus F2 sine of 20 degree minus F1, right? So what is in this case the net force in y, right? It's going to be 0. So 0 newtons equals to what is F3 is unknown, is what we have to find, plus what is F2 in this case, F2 sine of 20 is 6.0 newtons sine of 20 degree minus what is F1. F1 is just 5 newtons. So we have here 0 newtons equals to F3 6 sine of 20. It would be, let us do the calculation real quick. Let me pick my calculator, and then I have 20 sine times 6.0. This is 2.05, right? It is 2.05 newtons minus 5.0 newton. This is like a 2.1 newtons, right? Minus 5.0 newtons. So we have here 0 newtons equals F3. So 2.1 minus 5.0 will be 2.9. So minus 2.9 newtons, right? I will be adding 2.9 to both sides, so we get that 2.9 newtons is equal to F3, right? So I know now that the direction that I took for F3 was correct, you know, so F3 points over really, and then, you know, if I want to express F3 as a vector, I'm going to say that F3 is 2.9 J newtons. And here we have, you know, the solution of this exercise. So we found the values of F3 and F4, and we express those values in terms of the components using the unit vectors I and j. So thank you for your attention. If you feel this exercise help you to understand better these topics, please subscribe to my channel, and thank you again for your attention.